Molecular diagnostics of infectious diseases is moving on from the simple targeted detection of specific organisms using PCRs, including large panels of PCRs, multiplex PCRs, and we're probably standing on the threshold of a new era in which we no longer look at targeted diagnosis, but broadly throwing a wide net into our specimens and seeing what's there. And of course, if once one does that using whole genome sequencing and metagenomic techniques, not just detecting nucleic acids, but also small molecules, proteins, we will be more and more reliant on things like artificial intelligence and machine learning to analyze the large number of data that we will be getting. And of course, this opens up a completely new aspect in terms of molecular diagnosis, and we'll have to relearn what we do with this data, much as we've learned in the past to differentiate what we find in culture, and microbiology reports are basically also filtered for possible and known pathogens. We're going to have to start this all over again with a whole new range of organisms, many of which we've never heard of before. And the question is, what kind of a role do they play? This is, of course, for many people who are skeptical about molecular diagnostics, fuel for the fire that, in fact, we're getting a lot of information that you don't really need. I mean, especially with panels, you're looking for one organism, the lab does a panel and you find a whole range of others, or one or other. What kind of a diagnosis do I make? Do I change my diagnosis? And using metagenomics and other larger arrays, this problem will become even larger. And with machine learning, perhaps we can learn better to discover or incorporate host molecules in order to distinguish between infection and contamination, or infection and colonization, what is part of our normal flora and where is perhaps the disturbed normal flora an indication of some kind of pathological process. These are all questions that molecular diagnosis involved people will be confronted with in the future. They will have to make decisions, some of them which will be wrong and have to be revised in the future, but many of which will develop, and I'm sure that in the next few years and even longer, a few decades, molecular diagnosis will play a greater and a greater role in the diagnosis of infectious diseases. You're possibly asking yourself the question, will cultural or the culture of specimens still play a role? Certainly for the next few years, culture will certainly play a big role. If molecular diagnosis or diagnostic methods can replace cultural methods, that I'm not really sure. Certainly one can construct ideas that it is replaceable, but I think the next few years will give us more information in terms of answering that question. So to sum it all up, molecular diagnostics is a very large field of diagnostic microbiology and infectious diseases. It incorporates a whole new aspect of host-pathogen interactions, which is very exciting, and it's a great field to be in at the moment. Thank you.